All right, lesson number 3 for the moles and stoic unit. We're going to be taking a look at how to convert moles to volume this time, or moles to liters in other words. So let's take a look at how to do this conversion. We'll take a look at 3 practice problems and we'll get you out of here. So moles to volume, how do we do it? Well, we're actually looking at the volume of 1 mole. So if I have a mole of gas, how many liters does that occupy? And this is what we actually say. For the volume of a gas, it actually relates to both temperature and pressure. So when we are measuring the volume of 1 mole of gas, we need to make sure that we have what we call STP, or a standard temperature and a standard pressure. STP means standard temperature and pressure. So when we're measuring the volume of 1 mole of gas, we always do it at 0 degrees Celsius. That's our standard temperature. And we always do it at a pressure of 1 atmosphere. When we do this, when we use 0 degrees Celsius and 1 atmosphere, we notice that 1 mole of gas will always occupy the same volume, and that is 22.4 liters. So we always say that 1 mole of gas at STP actually equals 22.4 liters. That's our conversion factor. 1 mole is equal to 22.4 liters. So let's take a look at where that is on our conversion chart. We are looking at this conversion chart now, this part of our conversion. We're looking at moles going to volume here. And it says right here that a mole is equal to 22.4 liters. That's the conversion factor we're going to be using for these problems. So just a quick review and then 3 practice problems for us to do. When I look at O2, oxygen, 2 molecules of oxygen, well, at STP, remember this just means standard temperature and pressure, we say that it has a volume of 22.4 liters because 1 mole is equal to 22.4 liters. Here's our calculations. If I have 1 mole of oxygen, the mole of oxygen goes on the bottom, and I'm going to multiply that by 22.4, giving me 22.4 liters of oxygen as a gas. And we also say that this 1 mole of O2 has a mass of 32 grams. This is the conversion that we were doing in the last video, where I would have moles on top. We looked at this conversion factor here. We would use the mass from the periodic table to do this. And I looked at the periodic table. If I have 2 molecules of oxygen, each with a mass of 16, they have a total mass of 32 grams. Right? That's what we looked at. So when I do this, 1 mole of oxygen goes on the bottom, multiply this by my 32. My mass of oxygen is 32 grams. So now we know 1 mole of oxygen, we know it both has a mass of 32 grams. That's what we did in the last video. And in this video, we're saying it has a volume of 22.4 liters. Let's look at how we can use this in some practice problems. So here we go. This one says, determine the volume in 6 liters, or excuse me, determine the volume in liters of 6 moles of SO2 at STP. Well, let's set this up and do this just like we've done any of our other problems. I'm going to take what I know and I'm going to put that over 1. I'm going to write this down here actually. 6 moles of SO2. Putting that over 1. Multiply by a conversion factor. You better know what goes on the bottom. Whenever I have up top here, has got to go down the bottom here. So I'm going to put the moles of the SO2 down on the bottom. That is a habit. Every time, all the time. That's how we got to do it. Let's look at our conversion chart to figure out how to use this. Well, I started out here in moles. So this is where I was. I'm in moles. Well, what am I trying to get to? Well, I'm trying to get to liters, which is another term for volume. That's what I want to get to. Well, here is my conversion factor. Let's just highlight this again one more time. And it says that 1 mole is equal to 22.4 liters. So how do I express this? Well, it says 1 mole, 22.4 liters. So that means when I write this, I'm going to have 1 on the bottom next to my moles and 22.4 liters of SO2 up on the top. Now I have moles on the top, I got moles on the bottom, so my moles are going to cancel out, and now I'm left in liters. That's the unit that I want to be. And just like we do all these problems, we got to multiply the tops together, multiply the bottoms together, and then divide. So I got 6 times 22.4 up on the top, and down on the bottom, I have 1 times 1. Multiply the tops together, and when I do that, I get 134. Video lag here. There we go. 134.4, sorry about the delay, over 1. Now 134.4 divided by 1, that's going to give me my answer, and that is 134.4 liters of this SO2 gas. That's what I have for my volume. So I'm saying that 6 moles of this gas is actually equal to this many liters of this gas. Let's do 2 more. So in this one, we're actually going a different direction. We're starting out in liters. So I'm going to take what I know and I'm going to put it over 1. I have 112 liters and it says CO2. So CO2 is what I'm going to put down here. I have 112 liters of CO2. Let's take that, put it over 1. And you know what goes on the bottom. Whatever unit I have up here, it goes down here. Remember, you're not bringing the numbers down. You're just bringing the units. And the units are liters of CO2. So I'm putting that down on the bottom. Now when I look at this problem, I'm actually starting in liters. So where does that put me on this flow chart? Well, liters is a measure of volume, so I'm actually starting down here, and I'm going back into moles, because they're asking me to figure out how many moles I have. So this time I'm going in this direction here. So how does that change my problem? Well, if we remember our conversion factor, it says that 1 mole is equal to 22.4 liters. So 1 mole is 22.4 liters. So how do I express this? Well, it says 22.4 liters, so the 22.4 has to go on the bottom this time with the liters. That's how I got to write this. So 22.4 goes down on the bottom, and up on top, I'm putting the 1 mole of the CO2. That cancels out my liters on the top and the bottom, and now I'm in my moles of CO2. So let's multiply across the top, let's multiply across the bottom, and do our division to figure out our answer. So in this one, I have 112 on the top, multiplied by 1. And on the bottom, I have 1, and I know it's hard to read, but that should say 22.4 because there's 22.4 liters for 1 mole. Multiply across the top, I have 112. Multiply across the bottom, I got 22.4, and now I have to do this division. 112 divided by 22.4. When I do that, I will be left with 5 moles of CO2. So that's my answer, 112 divided by 22.4. I have, in 112 liters, I have 5 moles of CO2. 5 moles of CO2 is my answer. Let's do another one. Alright, in this one, I'm actually starting with 2.6 grams of CO2. Let's take what we're given, and let's put that over 1. So I have 2.6 grams of CO2. Take that, put it over 1, multiply by a conversion factor. You know what goes on the bottom. Whatever units I had in the previous step, I had grams of CO2 on the top here. That's what's got to go down to the bottom. Let's take a look at where we're starting on our flow chart and figure out where we want to go. We are looking for the volume. I am starting in grams. Well, grams is a measure of mass, so I'm actually starting here, and I want to get down to here. Now you'll notice there is not an arrow that goes directly from mass to volume. There is, however, an arrow that goes to moles, and there is an arrow that goes from moles to volume. So I've actually got to do 2 steps in this problem. This is a 2-step problem. You can't do it in one. You got to do it in 2 steps. So my first step is to take the mass and convert it to moles. Well, how do I do this? Well, let's jog our memory from the last one. It says right here in my conversion factor that 1 mole is equal to the molar mass in grams from the periodic table. I got to look it up on the periodic table. So when I look it up on the periodic table, I have CO2, I have carbon, I have oxygen. There is 1 carbon here, and there are 2 oxygens here. Let's look at the mass of carbon. When I look it up on the periodic table, my mass of carbon is 12. When I look up the mass of oxygen on the periodic table, my mass is 16. Multiply these. 1 times 12 is 12, 2 times 16 is 32, and add them together to get the mass. These numbers right here, the 12 and the 16. I don't pull up my periodic table right now, but those are coming from the periodic table. I didn't pull it up because I didn't want to load another page here, but that's where those numbers are coming from. Remember that. We're looking at the periodic table to figure out the mass. I add these 2 together, and what I see is that I have 44 grams. So 1 mole of CO2 is actually equal to 44 grams. We got that from the periodic table. Let's plug this into this problem. I have 44 next to the grams, so that's what's got to go next to the grams in my conversion here. 44 grams, and that's equal to, we said, 1 mole of CO2. I got grams on the top, grams on the bottom, they cancel off. I have now just done this step right here. I've gone from mass to moles. I've now got to take another step, an additional step to go from moles to volume. So let's take a look at how to do this. Multiply by another conversion factor. You've got to do this all over. Let me just move this other stuff out of the way so we can see this a little better. And I'll just move this stuff up so you can look at that still. Slowly but surely. Alright, so now let's take a look at how to do this conversion. Moles to volume. How do we do this? Well, we do this the same way we've been doing this every time. Take this unit, put it down on the bottom. So my moles of CO2 down on the bottom. How do I convert it? Well, 1 mole is equal to 22.4 liters. That's what our chart is telling us. So 1 mole, it goes on the bottom, and the 22.4 liters of the CO2, that's what goes up on top. My moles are on the top, the bottom, they'll cancel off, and now I'm in the units I want to be. I'm in liters. So how do I do these calculations? Well, let's look at how to calculate this out. Up on the top, I've got 2.6 times 1 times 22.4. Down on the bottom, I've got 1, 44, and 1. So down on the bottom I got 1, I got 44, and I got 1. So when I do this across the top, I'm going to do 2.6 times 1 times 22.4. What I'll be left with is 58.24 on the top. And down on the bottom, I have 1 times 44 times 1. That's going to leave me 44 on the bottom. And divide 58.24 by that 44 to get your answer. And when I do that, I get a long number. We're going to round it to 2 decimal places, but I get 1.32. And this will now be liters of CO2. So a 2-step problem in here. You see I had to go from mass to moles first. Then I had to go from moles to liters or volume there. I can't go from mass directly to volume, so I had to do this 2-step conversion, taking what we did from the previous lesson and adding what we did from this lesson. 2-step problem. You guys can handle it. I know you can do it. Check out the video. Talk to me tomorrow if you have any problems. We'll do the worksheet in class and we'll see how we do. That's all for now.